Okay, this is the lecture 4 of this series of 8086 assembly programming and the first lab assignment, and this is the program for counting number of characters in a given string. Okay, so this line start with a semicolon. This semicolon indicates this is the comment line. Okay, so this comment line shows the name of your program. Okay, and in 8086 every comment line should start with a semicolon. Then the next line is model small. Model small is basically there are different types of model available in 8086, and this model, while you are doing 8086 programming, the memory assigned, the memory reserved in your main memory is 1 MB. Why? Because you know that 8086 is 20-bit address bus, so it can access 2 to the power 20, that is 1 MB of memory. So it can access 1 MB of memory. So the starting address is 40 in 16. You know 10 stands for 4 binary 0, and the last number is 16 5F. 5F means this 1F stands for 41. So like this is the initial address and this is the final address. Okay, so while you are going to write a program, out of 1 MB for data, while you are giving data, while you are saving variables, so while allocating variables, for that purpose data section is there, data segment is there, and for saving your program code, one code segment is available. Stack for accessing, if you are going to use any stacks, this is the stack segment. So that means these things are necessary, and if you are working within extra segment, that is the need of extra segment. That means while you are writing in program, this 4 segment minimum you need. So on the basis, there are some model defines. One is small is, before going to small, first a tiny model. Tiny model tells instruct inside the processor, inside the memory, you have to reserve the size of both data segment and code segment should be 64K. That means both size should be 64K. This is the size 64K. Both this is the size, data segment, code segment 64K. And if your model is small, out of this 1 MB, this code segment size should be 16K and your data segment size should be 16K. And for medium size model, your data segment size is 64K, but the code segment size, any size means if you want more size, you can, for one code segment 64K, no doubt. If you want more size allocation for your code segment, you can create another code segment. Means here number of code segment can be more. Okay, but in case of small data model, the number of code segment is 1, number of data segment is 1. And for case of compact model, your data segment any size, that means number of data segment is more for your program, and number of code segment is 1, that is 64K. For large model, for your program, you can use many number of data segment, many number of code segment. That's why the size is any size. This is for your model part. So while you are writing dot model small, that means out of this 1 MB, you are going to use 64 KB for your data segment, for storing your variables in your memory locations, and for storing your program, you are using this code segment. Okay, and that is 1 that is, this is 64K, this is 64K. Then next go for stack segment. This is the declaration of stack segment, dot stack 100. This is the size of your stack. That means it tells your processor to inside memory to assign, to create a stack segment, and its size is 100 hexadecimal. Like this it can be more. Okay, no problem. Then after that the data section starts, dot data. Here the data section starts. That in data section, what you are going to, that is for going to store programs, to creating variables. For that purpose the data section. So here the first data is variable var db 100 dup dollar. What is this? Is nothing. This is an array. Basically in your C program you know how to write array. Basically, let a simple example, int a of 5 equal to 1. What is the meaning? That means it is a array, it is a integer types of array, and the number of memory location is 5. from 0 1 2 3 4 5, and the initial value you can initialize any value, or this is let 1 2 3 4 5, this is the initialization. Like this you are going to initialize, this is the value. If you did not give anything, this is by default, this is the some garbage value it will store. This is the like in case of C program. Okay, and every element of this array, this is nothing but a of 0, this is the first element, like this a of 1, these are the elements of array. Every element size is a integer, means this is a 2 byte equal to 16 bit. This is the size of 16 bit. All elements are of 16 bit size. Exactly in case of 8086 assembly programming, this is the name of the variable. Okay, this is, you write this variable means inside your course in data segment a memory allocation started. This is the variable, and db stands for each element. See here 100 stands for number of elements is 100. Here number of elements are 100, and your db stands for each element of each element size is 8 byte. Okay, and db means data byte, defined byte. Okay, this is db means 8 bit. Okay, every element is 8 bit. This is a defined byte. Okay, every element is 8 bit size. Okay, and duplicate 100. Okay, number 100 means number of element size is 100, and duplicate dup dollar means initial value is dollar. Okay, initialize the value. If you did not mention anything, it may be garbage, it may be hold some garbage value. Since you are mentioned dollar here, the initial value is dollar. Okay, then next go for message. Message is a variable, and of a string type, enter the string. Okay, and this string end with dollar. This is dollar, this is the sign that your string ended here. In basically C program, every string end with the null, basically null string, null symbol. But here in case of your assembly, every string end with the dollar. And for every variable, what is the size? This is a db. db means data defined byte, means 8 bit will assure. For example, every element is enter. This is nothing. This is a string. Okay, this is a string, and this string, and this is declaration, and the value of the string is enter the strings. Okay, this is message. Then next is okay. So there are two variables. One is variable. This is a array, and second is a message. This is string. For that, both are mentioned, both are declared inside data segment. That means they are available inside the memory. Okay, this is the memory location. Let's go for your code segment. Here in the code segment, your program is available. Means here, okay, let's start dot code main proc. What is this? Remember this. This is nothing. This is the procedure. Remember, this is the declaration for procedure. Main procedure. Main is the name of the procedure. You can change main instead of main. You can use your name. Main procedure. This is the starting of the procedure, like in function in C. And under that, two lines are very important. This is to move ax comma r3 data. What is r3 data? Actually, this code, all the programs, all the important parts are inside the code segment. Okay, inside the code segment means this is the code segment. Okay, and this is the data segment. Data segment means the variable values are available in the data segment, but you are working now in code segment. How the code segment assess the values of the variables? So that means the code segment should access the value. For creating some link, this is the two line. This is r3 data. R3 data means it will return the base address of this data segment. Listen, this is the data segment. In the data segment, this is the data segment, and let this is the base address. Let base address initially just consider 40,000. This is the base address. Okay, so this is the base address of your data segment, and so it will return this value, will return to ax. You know ax, what is the size of ax? Ax is 16 bit. Okay, it's 16 bit means it is not going to hold the 5 means this is 40,000 means here 5 digit hexadecimal, and each hexadecimal is equal to 4 bit binary. So this is 20 bit. So but this is 16 bit. What it will hold? It will hold from right to left. That means 4,000. It will hold 4,000. It will hold only 4,000. Okay, and this data now available AX register, and this is AX register. Then AX register transfers move DS comma AX. That means here X register will transfer this value to the DS. Now DS, your data segment will hold this value 4000. Okay, this is data segment. Now data segment hold, and you cannot directly write here move DS address data, because while you are doing some operations, first you have to transfer this types of address or data to your accumulator AX, and accumulator, from accumulator you can transfer this data to the data segment. You cannot transfer this data directly, this base address directly to your DS register. DS register means your data segment registers. Okay, so data segment register holds the base address of logical base address of your real this is the real data segment. This is the real data segment logical address. Listen, this 4000 is not the real value. This is the logical address. Real address is the 40,000. Okay. Then after that, and this DS register and offset value, with the help of that your order is available within your boss interface unit. It will calculate the real 40,000 address. Okay, so we will see that later. Okay, then LEADX comma message, what is it stands for? LEADX comma MSC. MSC, you know, MSC is a variable of string type of variable, and a load effective address. LEA stands for load effective address. The message, what is the message location? This is the location. This is the location of the message. Okay. In the location address, it will give the effective address. Effective address means nothing but the offset address. It will give you the offset address. Otherwise, you can write here like this. Here you can write like this. Move. These both are same. Move DX, comma offset MSC. Both are same, because it will effective address or load the effective address. That means the DX is going to hold this DX. It is going to hold the offset address of MSC. What is the MSC? This is MSC, and from this location to this location, there is some offset value available. Let this offset value 3000. That offset value will be given to DX. Okay. After that, LEADX message. What is the value of message? Message value is enter the string. Okay. MSC value is enter the string. So remember that here LEADX means LEA stands for load effective address. Load, I think all of you know that different load effective address. So load effective address means where is in the string available MSC. Here it has a effective address. Remember, one is base address, another is effective address. Effective address means nothing, offset address. Okay, this is offset address. Actually, this is the memory location. This is the base address held by your DS, and from this location to this location there is offset value available. This offset value we have to transfer to DX, load effective address, this offset value. Otherwise we can rewrite this instruction like this, move DX offset MSC. That means both are same. That means this means a message, this variable offset value will move to DX. This and this both are same. Remember this. Okay. Then okay, move. Then after that, after this message come to here, message means it will give means let this is here 3000 is the location offset value. This 3000 will hold by your DX register. Okay. 3000 hold by your DX register. Then after that there is a function move AH comma 09 and INT. What is the role of these two? Remember that INT 21. All of you know, you have to understand 21. What is this? This is a interrupt. This is a software interrupt. This is a software interrupt. And what is its work? Software interrupt. What is, okay, check this interrupt. This is a software interrupt, and it has a different function. It has 100 functions and 100 functions. Basically it performs it works with test data. It has 100 functions. So how it will perform, which type of operation it is going to perform, how it will know. So to know that it's a number start with 01. It has nearly 100 functions available. Okay, it has 100 functions. It has 100 functions available. That means which type of operation your INT is going to perform, how it will know. For that purpose, you have to transfer which type of operation you want to do its value to edge register. Remember, Now age register hold 09. That means in 09 it already defined which type of operation your int 21 is going to perform. So let me show you what are the functions 21 can do. Just see here. 1 minute. See, this is 01. 01. All the functions are of, if your age register hold 01, int 21, which type of operation it will perform? Basically it will perform reading a single character from keyboard and echo it on monitor. That means whatever value will give you from the keyboard, it show in your monitor. That means it is nothing but exactly it performs the work of your basically scanf. Actually it, while we are entering the in C we are entering the value from the keyboard using scanf. Like this, through 01 we can enter the value from the computer. So okay, you can read this. To get one character input in a variable in data segment, you may include the following code. For example, I want to give value to X register. How can I give? In scanf there is you have to understand how we enter value to the through scanf to a variable. So here if you want to give value to your X variable, what type of a code you have to write? You have to write h01. h01 means you are going to perform and you are going to give input from the keyboard. So age value 01, when age hold 01, this interrupt 21 int 21 will perform it takes the value from the keyboard. Okay, now and it saves the value at your AL register. What value you will supply, you will give that value held by your AL register. Then through, okay, now AL hold the value. From AL we can transfer the value to your X register. Okay, so like this is the for receiving input from the computers, and echo on the computer means while you are entering you can see what value you gave it. And age is equal to 02. What is the function? This function is, it is same as the function of your printf. This function print 8-bit data, whatever only it print 8-bit, it only accept 8-bit. That means whatever value stored in your DL register, that means whatever you want to print, you have to transfer to your DL or DX register. After you transfer this content to the DL or DX register, then only it can print on your screen. Okay, to print the character, let's see, let you want to print something. You have to first provide the value to your DL register, and if you write this code, it will print on your screen. So this is, remember, this is important to supply the input. You have to write age01 like this, and to print you have to write this format. Okay, and another is your basically your age, age 08. This is exactly same as this function, but difference is that while you are entering the value, this is takes input from the keyboard, this also takes input from keyboard, but while you are entering the value here, you can see what value you entered, but you cannot see what value you entered. So this is the only the two difference, nothing more is there. So we can study this. Now another is age 09, that is we are going to discuss. 09 means it is also same as 02, but the difference is it will print the whole string. This program output a string whose offset is stored in DX, while we stored the offset in DX register. DX register holds the offset value, and from this location, from this offset address, it will, and this DX register hold a offset value, and the whose offset value it hold means memory location offset value. That mobile location should be end with this dollar character, and from that location it takes the value and print on the screen. Okay, so I will show you in that program. No need to discuss here more. This is a program you can study yourself. Another function, and this is age value when force is. It is, remember, this is exit function. This is the return function, and your age 0 age, in this case actually while you are writing age equal 01, you can input one character. Okay, but while you are writing age equal 0 age, it will, we can give input of strings up to 255 character. Means at a time we can provide 255 character to our systems. Okay, so these are the functions, little bit functions. A lot of functions are available, but for our programming these functions are essential, so I mention here. Okay, so return to your program, right? So here, okay, so here what happened, message effective address now available in dx, that means offset value. So what is the offset value? 3000. This is the offset value of this location. So now it is available in your dx registers. AH09, that means 09 means I already told you, this means it, what offset value hold in your dx register, from that memory location it is going to start the strings on your screen. Okay, it will be string. What it will write on your screen? It will write on your screen enter the string. So your screen will show enter, your screen will show enter the string, enter the string. After your program it will show on the screen enter the string. Okay, and this will continue up to how many number of string it can, number of character it can be, up to the last ended with dollar. If okay, so remember, while you are writing any string type, you have to end with a dollar, so that through this it will print what are the content available in message, that is enter your string. This is transfer enter your string. You can check there, enter your string. After that we came here, move bl equals 0. Now bl equals 0. Okay, bl now 0. Now next, offset value of a var character. Var character offset value of what is the offset value? You can see here, this is your variable array, its offset value is 1000. Okay, that means it's the offset value. So now variable offset value is offset value of variable 1 equal to 1000 hexadecimal. It will move to SI. Now SI hold this SI register. Remember that SI is the offset for data segment. Okay, so it will hold the offset value of data segment. Okay, now it will hold the offset value, and you know what is the data segment, data section hold, data segment hold, already I told you 4000. Now this is the your it will hold the base address. Okay, it will hold their offset address, offset for base section. Okay, so now here your level 1 start, move AHL. Move AHL means move AHL and IND21. This is the enter. What operation it will do? It takes keyword, it takes a character from your keyboard. Okay, now let I enter A. So through this I enter A. Here what will happen? Compare AL13. I already told you. Now whatever I entered through this two line, it will save at AL location. So now AL hold 13 A. Now compare AL13. 13 what is? 13 is the ASCII value of enter. If you did not enter anything, you die from the beginning. If you press enter, it becomes equal and jump equal. That means it will go to print string. I already did this. So here, while you are doing compare operation, now AL hold A. What is the ASCII value of A? ASCII value of, you can check there, I think 65, or you can check there ASCII value of A. What is the ASCII value of capital A? 65 or 90? Oh, sorry. Here capital A stands for 65. You can see here. So what happening? So here A, ASCII value of A is 65 and your 13, ASCII value 13. This is the compare operation. Okay, these are not same, these are not equal. That means jump equal, this will not happen. It will jump when this is equal. Now it will not jump. Now go to this step, move SI comma AL. That means what? AL now hold what? Now AL hold your value A, capital A. Okay, it will store at SI. What is SI? SI, I told you, SI hold the base address. Remember that this is one addressing. Okay, so in this addressing scheme, what is happening? AL will store, if it is like this, move SI AL, then what will happen? AL value, that means A will store SI, but here it is nothing. This is the memory operation. That means AL value will store at the memory location of SI. What is SI hold? SI hold 1000. So what is the value of SI? Offset address is 1000. In 1000 location, the value 8 will store. That means here, see, 1000. What is 1000 location? This is 1000. In this location, the value A will be stored. Remember that. Okay, You I think understand which type of addressing. This is different types of addressing modes available. Immediate addressing mode available, and the indirect addressing mode. I think this is indirect addressing mode. Okay. Though remember that SI hold the memory location 100, 1000. In 1000 the value will store. Okay. Okay. SI register hold 1000. In 1000 memory location the value A now stored. Okay. So after that what will happen? Increment SI. Now SI will increment, and SI will increment means what? It was here 1000, this location 1000 left, and after that 1 byte will increment. Next location this is the location of SI, and in BL, what was BL? Initially BL was 0, now it becomes 1. Okay, now BL is 1. After that jump AL means it will jump to again this location. Okay, again this location means again this operation will start. It asks for another key to enter from the keyboard. Let I enter another key. Here A is available, I enter. Then second time I want to enter L. Okay, A, then what will same operation will happen? Compare this, it will check the, it will compare the ASCII character 13 with the L, and the L character. You can find the ASCII value of L is different, it will not equal, so there is no jump operation. Again move to here, move SI means whatever value I gave, that is L value I gave, that L value store at L location. That L location value now copy to here. Where it will copy? It will copy to that location that hold by SI. SI hold 1000, in 1000, not 1000, SI incremented. SI now indicate to this location. Here L will store. Okay, now BL incremented. Now we get 2 string. Now BL value is 2. Then again what will happen? Jump to this. This operation repeatedly happen. Okay, through this operation you can enter as much as number you want, as many as number you can want. Through this operation you can provide. Okay, so here let I insert alloc. After I insert alloc, remember first I entered A, that's why BL was 1. Then I entered L 2. Then after every time this BL is incremented. So 4, after I gave K 4, after K let next operation. While I am here, I gave the value, I gave nothing, I just entered. While I press enter key, it compare AL is hold. Now enter key value is nothing but 13. Now it is equal condition satisfied. Then it will jump to string, it will jump to this location. I already told you how it will happen. It will print what will print. Now DL hold the ASCII value of basically BL hold. What is the value BL hold? BL, how many character I entered? I entered AL. Okay, 4 character. So now BL is 4. So 4 is available here. Now it will happen, add the value 48. Why 48 will add? I told you we have to supply the ASCII value of 4. So 4 plus 48 is equal to 52. Okay, so now this 52 with the help of AH2 means it will print on the screen ASCII value INT21. This 2 line is used to print the value, what is ASCII value, what is available in DL register. So it will print on the screen. Now print now. Okay, so now what is DL hold? DL hold BL already transferred 4 to your DL, then our DL plus 4, that is this result hold by your DL register. So this 52 will print on the screen. I already told you. So let's see what is the ASCII value of what is the 52 hold stands for. 52 is 4. Remember this is decimal equivalent of 4 ASCII value. Okay. Okay, so this will print on the screen. After printing that, it will perform the exit operation. Okay, so like this you can run. And another thing I want to say here, this program is written maximum it can display 9 character, because you see here every time you are adding the value. For 0 you are 48. Okay, for if the string size is 7, it will, if string size is 9, so 9 plus 48, it is crosses the range. Remember that. If it crosses 50, let you supply 10. Okay, after you, so 10 plus 48, it will becomes how much? 58. 50. When it becomes 58, it will display column. So remember that this is program for printing maximum 9 character. Okay. through this it will print what are the content available in message, that is enter your string. This is transfer enter your string. You can check there, enter your string. After that you came here, move bl equals 0. Now bl equals 0. Okay, bl now 0. Now next, offset value of a var character. Offset value of what is the offset value? You can see here, this is your variable array. Its offset value is 1000. Okay, that means it is the offset value. So now variable offset value is offset value of variable 1 equal to 1000 hexadecimal. It will move to SI. Now SI hold this SI register. Remember that SI is the offset for data segment. Okay, so it will hold the offset value of data segment. Okay, now it will hold the offset value, and you know what is the data segment, data section hold. Already I told you 4000. Now this is the your it will hold the base address. Okay, it will hold their offset address, offset for base section. Okay, so now here your level 1 start, move AHL. Move AHL means move AHL and IND21. This is the interrupt. What operation it will do? It takes keyword, it takes a character from your keyboard. Okay, now let I enter A. So through this I enter A. Here what will happen? Compare AL13. I already told you. Now whatever I entered through this two line, it will save at AL location. So now AL hold 13 A. Now compare AL13. 13 what is? 13 is the ASCII value of enter. If you did not enter anything, you from the beginning, if you press enter, it becomes equal and jump equal. That means it will go to print string. I already did this. So here, while you are doing compare operation, now AL hold A. What is the ASCII value of A? ASCII value of, you can check there, I think 65, or you can check there ASCII value of A. What is the ASCII value of capital A? 65 or 90? Oh, sorry. Here capital A stands for 65. You can see here. So what happening? So here A ASCII value of A is 65 and your 13 ASCII value 13. This is the compare operation. Okay, these are not same, these are not equal. That means jump equal, this will not happen. It will jump when this is equal. Now it will not jump. Now go to this step, move SI comma AL. That means what? AL now hold what? Now AL hold your value A, capital A. Okay, it will store at SI. What is SI? SI, I told you, SI hold the base address. Remember that this is one addressing. Okay, so in this addressing scheme, what is happening? AL will store, if it is like this, move SI AL, then what will happen? AL value, that means A will store SI, but here it is nothing. This is the memory operation. That means AL value will store at the memory location of SI. What is SI hold? SI hold 1000. So what is the value of SI? Offset address is 1000. In 1000 location, the value 8 will store. That means here, see, 1000. What is 1000 location? This is 1000. In this location, the value A will be stored. Remember that. Okay, you I think understand which type of addressing. This is different types of addressing modes available. Immediate addressing mode available, and the indirect addressing mode. I think this is indirect addressing mode. Okay, though remember that SI hold the memory location 100, 1000. In 1000, the value will store. Okay, SI register hold 1000. In 1000 memory location, the value A now stored. Okay, so after that, what will happen? Increment SI. Now SI will increment, and SI will increment means what? It was here 1000, this location 1000 left, and after that 1 byte will increment. Next location, this is the location now SI, and in BL, what was BL? Initially BL was 0, now it becomes 1. Okay, now BL is 1. After that, jump AL. Jump AL means it will jump to again this location. Okay, again this location means again this operation will start. It asks for another key to enter from the keyboard. Let I enter another key here. A is available, I enter. Then second time I want to enter L. Okay, A, then what will same operation will happen? Compare this, it will check the, it will compare the ASCII character 13 with the L and the L character. You can find the ASCII value of L is different, it will not equal, so there is no jump operation. Again move to here, move SI means whatever value I gave, that is L value I gave, that L value store at L location, that L location value now copy to here. Where it will copy? It will copy to that location that hold by SI hold 1000 in 1000, not 1000, SI incremented. SI now indicate to this location, here L will store. Okay, now BL incremented, now we put two string, now BL value is 2. Then again what will happen? Jump to this operation repeatedly happen. Okay, through this operation you can enter as much as number you want, as many as number you can want. Through this operation you can provide. Okay, so here let I insert alloc. After I insert alloc, remember first I entered A, that's why BL was 1, then I entered L 2, then after every time this BL is incremented. So 4, after I gave K 4, after K let next operation. While I am here, I gave the value, I gave nothing, I just entered. While I press enter key, it compare L is hold now enter key value is nothing but 13. Now it is equal condition satisfied, then it will jump to string. It will jump to this location. I already told you how it will happen. It will print what will print. Now DL hold the ASCII value of basically BL hold. What is the value BL hold? BL, how many character I entered? I entered AL. Okay, 4 character. So now BL is 4. So 4 is available here. Now it will happen add the value 48. Why 48 will add? I told you we have to supply the ASCII value of 4. So 4 plus 48 is equal to 52. Okay, so now this 52 with the help of AH2 means it will print on the screen ASCII value INT21. This 2 line is used to print the value, what is ASCII value, what is available in DL register. So it will print on the screen. Now print now. Okay, so now what is DL hold? DL hold BL already transferred 4 to your DL, then our DL plus 4, that is this result hold by your DL register. So this 52 will print on the screen. I already told you. So let's see what is the ASCII value of what is the 52 hold stands for. 52 is 4. Remember this is decimal equivalent of 4 ASCII value. Okay, so this will print on the screen. After printing that, it will perform the exit operation. Okay, so like this you can run. And another thing I want to say here, this program is written maximum it can display 9 character, because you see here every time you are adding the value. For 0 you are 48. Okay, for if the string size is 7, it will string size is 9. So 9 plus 48, it crosses the range. Remember that. If it crosses 50, let you supply 10. Okay, after you, so 10 plus 48, it will becomes how much? 58. 50, when it becomes 58, it will display column. So remember that this is program for printing maximum 9 characters. Okay, now we are going to run the program practically, that program for counting number of characters in a given string. So for that purpose, first go to your DOS box. Okay, so let's start to run the programs. Okay, this is the DOS box. Okay, just take it in the middle. Okay, so you know that no need to tell what is Z. Z is this is the virtual disk. This is not available in your system. So for that purpose, we have to go C drive. In C, under C drive, our MP folder available. We have to mount here. Mount C MP folder. My MP folder. I have to mount that. Then C colon. then you have to here you have to start the running. Why I write c.mp? This is the location. You check that this is the location where your code are available. First check that, make it clear first. This is the location. See here in C drive, under that there is MP folder available. Under the MP folder my program is here available. I already written the program, so that I have to give this path. Remember that before running the program you have to type the program in the notepad and save here. Okay, you save here, so you can see the program also, or if you want to some edit operation you can open here lab1 dot asm program. Okay, so this is the program. You can see here program for counting number of characters in the given string. This is the program available. I have already written and I already saved this, so no need to save, no need to do any operation, just exit from here. Okay, after that first I'm going to run masm. How to compile this program? First masm, full name of the program lab1 dot asm. Okay, now this is object file generating, source listing, cross references, these are doing inside. So now object file generated. Next thing is I have to link that, link lab1 dot obj file, because object file already generated. If you want to see that, you can see here in here that is already available. Obj, now exe file is going to generate. Yes, exe file lab1.exe. So after that I want to see my result, lab1.exe. I want to run that file. So enter the string name. Let my I am going to give my name. Okay, my name is Vichitra, so I give here that is BICHI 38, so number is 8. Okay, I got it. If I want to run again, I want to give another number. Let allow my other number, another name, so that is 4. Let my run my another, I have another name, Nanda, so this is 5. So all the things are coming, you can check here. Okay, so thank you for watching.